Good morning, guys. Happy Friday. So today we're going to go over section 1.6, which is absolute value. This is the last section for chapter 1, which means that next week we will have a chapter 1 quiz. So before we get started, let's do a little introduction problem. So looking at this, you are riding in an elevator and decide to find how far it travels in 10 minutes. You start on the 3rd floor and record each trip in the table. How far did the elevator travel in all? Justify your answer. Now, it's really important when we're thinking about distance, it's very important to remember that when you're talking about where you're moving, it can never be negative. I can walk 3 steps forward or I can walk 3 steps back, but I'm never moving in a negative direction. I'm always moving a total of 3 steps. So how far did the elevator travel in all? So let's look at this table here. It shows us how many floors we traveled. So on the first trip, we went up 8. On the third trip, we went up 9. And on the fifth trip, we went up 7. So I want to figure out how many floors I traveled up in total. So 8 plus 9 plus 7 gives me a total of 24 floors moving up. And in those 10 minutes, on my second trip, I went down 6 floors, and on the fourth trip, I went down 3 floors. So I moved a total of 9 floors down in those 10 minutes. Now, looking at these numbers, you would think we have to do 24 minus 9, but we don't have to do that. We are talking about distance again, so it always is positive. So even though we went down 9 floors, we were still traveling 9 floors in total. And here we went up 24, so we're still traveling 24 floors. So to figure out the total, we are going to add 29 floors plus 9 floors, which gives us a total in 10 minutes. We traveled 33 floors. And this is very important to remember when we're talking about absolute value. So the absolute value of a real number x, written absolute value of x, is the distance from 0 on the number line. And when we're talking about distance, it always has to be positive. So if we represent absolute value with numbers, we can say the absolute value of 4 is equal to 4, and the absolute value of negative 4 is equal to 4. If we're talking about it in symbols, the absolute value of x is equal to x if x is greater than or equal to 0. And the absolute value of x equals negative x if x is less than 0. So again, we're talking about absolute value. Our solution is always going to be positive. The reason this works is we're talking about an x value less than 0. So if we take, for example, negative 2, if we have the absolute value of negative 2, that's going to be equal to negative x. So negative, negative 2. So absolute value of negative 2 is going to be positive 2. Negative, negative 2 cancels out, and it becomes 2. So it will always be positive when you're talking about your distance. So an absolute value has a variable within the value sign. For example, the absolute value of x is equal to 5. Above, the value of x can be 5 or negative 5, since absolute value of 5 and the absolute value of negative 5 both equals 5. So when we're talking about absolute value equations, you're going to have a variable inside of your absolute value, and that's going to give you two solutions, one where it's positive and one where it's negative. So there's two solutions to absolute value of x equals 5, negative 5 and positive 5. And on our number line, we just represent that by putting a closed circle at each of those points. So let's look at our first example. What is the solution of absolute value of 3x plus 2 is equal to 4? And we want to graph our solution. Like I just said, we're going to have two separate solutions. So we're going to make two equations to solve for this one. The first one is going to be exactly the same as our original equation, just without the absolute value symbol. So 3x plus 2 equals 4. The other solution, we want to figure out an x value that makes us have negative 4 inside this absolute value, because that's still going to give us a solution of 4. So this equation is going to be 3x plus 2 is equal to negative 4. So when you're creating your second equation, you're just flipping the sign or making it negative. So now we're just going to solve. So subtract 2 from both sides. So we're left with 3x is equal to 2. Divide both sides by 3, and we have our first x value as 2 over 3. For our second equation, 3x plus 2 equals negative 4. Subtract 2 from both sides. So 3x is equal to negative 6. To isolate x, we're going to divide both sides by 3, and we get x equals negative 2. So into our original equation, we can plug in 2 over 3 for x, or negative 2 and get the solution of positive 4. So to graph on our number line, we are going to plot both of these points. One x value is at negative 2, so I'm putting a closed circle at negative 2. The other x value is at 2/3, so that's between 0 and 1, closer to 1 on your number line. And you can always check by plugging back into your original equation. Let's look at another example. What is the solution of 3 times the absolute value of x plus 2 minus 1 equals 8? So now when we're doing these problems, we are going to have to create two equations, but you have to isolate your absolute value first. You have to get this by itself before you can split and create your two equations. So we're going to use our order of operations to get 3 times x plus 2, absolute value of x plus 2 by itself. We're adding 1 to both sides. So we have 3 times the absolute value of x plus 2 is equal to 9. Divide both sides by 3, and we have the absolute value of x plus 2 is equal to 3. And now once you have your absolute value isolated on one side of your equation, you can create the two equations. So the first one is exactly the same. X plus 2 is equal to 3. The second one is x plus 2 equals negative 3. When we solve our equation to the left, subtract 2 from both sides, so x is equal to positive 1. When we solve our equation on the right, subtract 2, so we have x equals negative 5. So we can plug in negative 5 for x or positive 1 for x and get the same solution. On our number line, we are going to put closed circles at negative 5 and at positive 1. Those are the only two solutions that make this absolute value equation true. Next example, what is the solution of 2 times the absolute value of x plus 9 plus 3 equals 7? So again, first we have to isolate our absolute value. So I'm going to subtract 3 from both sides. That leaves us with 2 times the absolute value of x plus 9 equals 4. Divide both sides by 2. And we have absolute value of x plus 9 equals 2. Once you have your absolute value isolated, we can split and create our two equations. First one stays exactly the same, x plus 9 equals 2. For the second one, we make our right side negative, so x plus 9 is equal to negative 2. Solve both, so I'm going to subtract 9 from both sides, and we're left with x equals negative 7. Subtract 9 from both sides over here, and we are left with x equals negative 11. So our two solutions that make this absolute value equation true are x equals negative 7 and x equals negative 11. So as we know, the distance from 0 on the number line cannot be negative. We talked about that a bunch of times already today. Therefore, some absolute value equations, such as the absolute value of x equals negative 8, have no solution. So for this problem, there is nothing that we can plug in for x to get a solution of negative 8. So that's no solution. It is important to check the possible solutions of an absolute value equation. One or more of the possible solutions may be extraneous. And an extraneous solution is a solution derived from the original equation that is not a solution of the original equation. So sometimes when you're solving these equations, you might get a value for x, but then when you plug it back in, it doesn't work. So you always have to check. If you get an answer, but then it doesn't work when you plug it in, that's called an extraneous solution. So let's look at an example. What is the solution of absolute value of 3x plus 2 equals 4x plus 5? So we already have our absolute value isolated. Now we can create our two equations. The first one stays exactly the same. We just drop the absolute value. So 3x plus 2 equals 4x plus 5. Our second equation, 3x plus 2 stays the same, and now we just change the sign of the right side. So because it's two terms, we have to put this in parentheses. We're multiplying everything by negative 1. So it's negative 1 times 4x plus 5. Very important. If you have two terms, you have to flip the sign of every term. So now on our first equation, 3x plus 2 equals 4x plus 5, I want to isolate my variable. So I'm going to subtract 3x from both sides and subtract 5. When we do this, we are left with negative 3 is equal to x. So that's one solution. For the equation on the right, we're going to distribute this negative, so we have 3x plus 2 equals negative 4x minus 5. Now to solve for x, I'm going to add 4x to both sides and subtract 2. When we solve, we get 7x is equal to negative 7. Last step, divide both sides by 7, and we have x is equal to negative 1. So we have two values for x, but now we want to plug in and check that these work. So we're going to plug back into our original equation. So we have the absolute value of 3 times x, which is negative 3, plus 2 equals 4 times negative 3 plus 5. So when we solve this, we have the absolute value of 3 times negative 3 is negative 9 plus 2 equals negative 12 plus 5. So negative 9 plus 2 is the absolute value of negative 7. Negative 12 plus 5 is negative 7. Absolute value of negative 7 is positive 7, which does not equal negative 7. So although we have this as a solution, when we plug it back in, it does not work. So this is an extraneous solution. Extraneous. So when we solve, we get it, but it does not work when we plug it in. The absolute value is negative. The distance in this case, they tell us it's negative, and that is not possible, so this one does not work. So let's plug in and check when x equals negative 1. So we have the absolute value of 3 times negative 1 plus 2 equals 4 times negative 1 plus 5. So when we solve this, 3 times negative 1 plus 2, negative 3 plus 2 gives us the absolute value of negative 1 equals 4 times negative 1 is negative 4 plus 5. Absolute value of negative 1 is positive 1. Positive 1 equals 1, so this one checks out, and the only solution that works in this case is x equals negative 1. So although when we solve, we got two solutions, the only one that works when you plug it back in is x equals negative 1. So it's very important that you check your answers when you're doing these types of problems. Let's try another example. So pause this video, take a second, isolate your absolute value, and then solve for your variable. So we have, what is the solution of 5 times the absolute value of 6 minus 5y plus 5 equals 5y minus 30. So notice all of our terms right now are divisible by 5. So we can start by dividing everything by 5 before we move using any addition or subtraction. When we do that, we get the absolute value of 6 minus 5y plus 1 equals 3y minus 6. Now we only have one step left to isolate the absolute value, subtract 1 from both sides. And we're left with absolute value of 6 minus 5y is equal to 3y minus 7. I'm going to rewrite this equation at the top so we have room. 6 minus 5y absolute value equals 3y minus 7. And I'm going to erase some of this work so that we have room to solve. So now once you have the absolute value isolated, we have to create two equations. The first is exactly the same. 6 minus 5y equals 3y minus 7. The other, 6 minus 5y equals, now we have to multiply everything by negative 1. So negative 3y minus 7. To solve our equation on the left, we're going to add 5y to both sides and add 7. So 6 plus 7 gives us 13 is equal to 8y. Last step to solve for y, divide both sides by 8, and we can leave this as a fraction. Y is equal to 13 over 8 for our first solution. For our equation on the right, we're going to distribute this negative. So we have 6 minus 5y equals negative 3y plus 7. I'm going to add 5y to both sides and subtract 7. When we do this, we are left with negative 1 is equal to 2y. Last step to solve for y, we're going to divide both sides by 2, and y equals -1/2. So our two solutions for y are y equals 13/8 and y equals -1/2. Now, before we can say for sure, we have to plug in and check to make sure both of these work. So take a second, you can pause this video and plug in and check. So when you plug both of these y values back into the original equation, you will find that neither of them work, which means we have no solution, so both of these are extraneous. Both solutions are extraneous, which means that we have no solution that works for this absolute value equation. So last example for absolute value equations, we have 2 times 5x minus 2 plus 3 equals 4x plus 31. The first thing we're going to do is subtract 3 from both sides of our equal sign, and we're left with 2 times 5x minus 2 equals 14x plus 28. To isolate our absolute value, we're going to divide both sides by 2, and we're left with the absolute value of 5x minus 2 is equal to 7x plus 14. So absolute value of 5x minus 2 equals 7x plus 14. I'm going to erase down here so that we have some room to work. Now we are going to create two equations with our absolute value. So the first one is exactly the same. 5x minus 2 equals 7x plus 14. The second one, we are going to keep the left side the same, 5x minus 2. And then we're going to multiply everything on the right side by -1. So -1 times 7x plus 14. On the left side, we're going to subtract 5x from both sides to get our variables on the right, and subtract 14 to get our constants on the left. When we do that, we're left with -16 is equal to 2x. To solve for x, we're going to divide both sides by 2, and we're left with x is equal to -8. On the right side, when we solve, first we have to distribute this negative, so we have 5x minus 2 equals -7x minus 14. Add 7x to both sides. So our variables are on their left, and add 2, so our constants are on the right. And now we're left with 12x is equal to -12. Last step to solve for x, divide both sides by 12, and we have x is equal to -1. Now we have to check whether either of these solutions are extraneous. So plug x back in for your original equation, and we check for -8. We're plugging into absolute value of 5 times -8 minus 2 equals 7 times -8 plus 14. 5 times -8 is -40 minus 2 is -42 in our absolute value, which is equal to 7 times -8 is -56. -56 plus 14 is -42. Absolute value of -42 is +42, which is not equal to -42, which means that -8 is an extraneous solution. It does not work when we plug it back in. So now let's check for -1. When we plug -1 in, we have the absolute value of 5 times -1 minus 2 is equal to 7 times -1 plus 14. 5 times -1 is -5, minus 2 is -7. Absolute value of -7 is equal to 7 times -1 is -7 plus 14 is +7. Absolute value of -7 is 7, which is equal to 7, so this solution checks out. So the only solution that works for this absolute value equation is x is equal to -1. So that's our last example for absolute value equations. Now let's talk about absolute value inequalities. So the solutions of the absolute value inequality, absolute value of x is less than 5, includes values greater than -5 and less than 5. This is the compound inequality, x is greater than -5 and x is less than 5, which you can write as -5 is less than x, which is less than 5. So it's similar to how we solve our equations. When we're making our equations, we split it up into two separate equations with one +5 and one -5. Now with our inequalities, we're going to do the same thing. We're going to create an inequality with positive 5 and an inequality with negative 5. The only difference now is that when we create our inequality with negative 5, we also have to flip the symbol. So when we flip the symbol, that creates a compound inequality. So our solution is going to be in a range now between negative 5 and positive 5. So let's start by looking at examples for solving the absolute value inequality for the absolute value of A is less than B. And remember from last lesson, we have two types of compound inequalities. There's less than and there's greater than, and an or. Less than we can think about as less than. That means it is an and compound inequality. That means which our shading is going to be in between our two solutions or going towards each other. So the next two examples that we're going to be looking at are and problems because they are less than or equal to. So the first example, what is the solution of the absolute value of 2x minus 1 is less than 5? Graph the solution. So we have our absolute value isolated already. So all we have to do is create the compound inequality. So on the left, we're going to add negative 5 is less than 2x minus 1, which is less than 5. So we need to isolate x in the middle of our compound inequality. So we're going to add 1 to every side of our symbols. When we do that, we have negative 5 plus 1, which is negative 4, is less than negative 2, which is less than 6. Last step to solve for x, we're going to divide everything by 2. When we divide everything by 2, we're left with negative 2 is less than x, which is less than positive 3. And here's our range of solutions that's going to make this inequality true. When we graph the solution on a number line, we're going to have three values, negative 2, 0, and 3. Three values are fine when you're graphing on your number line. We're talking about less than and greater than, so we're going to have open circles at both of these solutions. If we start reading from the middle, we have x is greater than negative 2, which means we're shading to the right, and x is less than positive 3, so we're shading to the left. So our solution is just going to be between negative 2 and positive 3, not including those values for this absolute value inequality. The next example, we have the absolute value of 3x minus 4 plus 1 is less than or equal to 9. So we need to isolate our absolute value by subtracting 1 from both sides. When we do that, we have the absolute value of 3x minus 4 is less than or equal to 8. So now we're going to create our compound inequality. So negative 8 is less than or equal to 3x minus 4, which is less than or equal to positive 8. When we're isolating x, the first thing to do is to add 4 to every side of our inequality symbol. And we're left with negative 4 is less than or equal to 3x, which is less than or equal to positive 12. Last step to solve for x, we're going to divide everything by 3, and we're left with negative 4 over 3 is less than or equal to x, which is less than or equal to positive 4. So this is the range of values for this inequality. And now we have to graph on our number line. So on our number line, we're going to have negative 4 over 3, 0, and positive 4. Now for this graph, we have a closed circle at negative 4 over 3 and a closed circle at positive 4 because we're talking about greater than or equal to and less than or equal to. And for this solution, we're going to shade in between. When we start with less than or equal to, it's an and. So we're shading in between these two values. So any value for x from negative 4 over 3 to positive 4, including those solutions, is going to work for this absolute value inequality. And the last type of inequality that we're going over in this section are solving the absolute value inequalities when absolute value of A is greater than B. So greater, we can think about great or, which is going to be an or inequality. So our shading is going to be in opposite directions on our number line. So that's a little hint when you're thinking. So just by looking at the symbol, you're able to figure out if it's an and or an or. So let's look at an example. What is the solution of 2 times 2x, absolute value of 2x plus 4 minus 1 is greater than 11? And we're going to graph this on a number line. First thing we want to do is isolate our absolute values. So we're going to add 1 to both sides. And we're left with 2 times 2x plus 4 is greater than 12. Next thing we want to do is divide both sides by 2. And we have the absolute value of 2x plus 4 is greater than 6. But now when we're talking about or, if you start with greater or greater than or equal to, we're going to create two separate inequalities. So the first one is going to stay exactly the same. 2x plus 4 is greater than 6. But now we're talking about or. So we're going to separate these inequalities with or. And the other inequality is going to be 2x plus 4 is less than negative 6. So the two important changes that happen in this inequality are that you flip the symbol and you flip the sign of your solution. So anytime you change from a positive to a negative, you have to flip your inequality symbol. So because we go from positive 6 to negative 6, our symbol goes from greater than to less than. And now we can solve these separately. So for our expression on the left, 2x plus 4 is greater than 6. We're going to subtract both sides by 4 first. And we're left with 2x is greater than 2. Divide both sides by 2, and we're left with x is greater than 1. For the expression on the right, we're going to subtract 4 from both sides, and we're left with 2x is less than negative 10. Last step to isolate x, divide both sides by 2, and x is less than negative 5. So these are the ranges for our solutions. Now, when we graph this on a number line, we have negative 5, 0, and positive 1. X is less than negative 5, so we have an open circle at negative 5, and we're shading everything to the left all the way to negative infinity. And x is greater than 1, so we have an open circle at 1, and we're shading everything to the right all the way to positive infinity. And the last example for this section, we have what is the solution of 1/2 times 5x, absolute value of 5x plus 10, minus 4.5 is greater than 3, and graph the solution. So first, we are going to add 4.5 to both sides. And we're left with 1/2 times the absolute value of 5x plus 10 is greater than 7.5. To isolate our absolute value, next we're going to multiply both sides by 2 to get rid of this fraction. And we're left with absolute value of 5x plus 10 is greater than 15. So now we have gotten our absolute value by itself. We have to create our two inequalities. The first one stays exactly the same. 5x plus 10 is greater than 15, or 5x plus 10 is less than negative 15. So you're changing your solution to from a positive to a negative, and you're flipping your inequality symbol. Now we can solve. 5x plus 10 is greater than 15. Subtract 10 from both sides. And we have 5x is greater than 5. Divide both sides by 5, and we have x is greater than 1. On the right, we're doing the same thing. Subtract 10 from both sides. We're left with 5x is less than negative 25. Divide both sides by 5, and we have x is less than negative 5. And when we graph this solution set on our number line, we have negative 5, 0, and positive 1. X is less than negative 5, so we have an open circle at negative 5, and we're shading everything to the left all the way to negative infinity. And x is greater than 1, so we have an open circle at 1, and we're shading everything to the right to positive infinity. So without solving, 2 times the absolute value of x plus 3 is greater than or equal to 16. Describe the graph of its solution. So we just did a couple problems like this. Without solving, without doing anything, just by looking at this inequality, we're able to tell what kind of graph it's going to be on our number line, just by looking at the symbol. So we have greater than or equal to. Great or tells us that this is going to be an or inequality. which means that the shading is going to be in opposite directions. So because it's greater than or equal to, we're going to have closed circles at our solution points, and we're going to be shading in opposite directions from positive infinity to negative infinity. If the symbol was less than or equal to, then it would be less than, which tells us that is an and compound inequality. So the shading would be between the 2 points on our solution. So without graphing, without doing anything, just by looking at the inequality symbol, we're able to tell what the shading would look like on our number line. And that takes us into the concept summary for this section. So if we have, and the absolute value is equal to a number, we're just going to have the 2 points on the number line shaded. So there are 2 solutions when we're talking about an absolute value equation, unless some of them are extraneous. For inequality, for x is less than a, or x is less than or equal to a, it is an and inequality. For x is greater than a, or x is greater than or equal to a, it is an or inequality. So we're shading in opposite directions. And you have the definitions in the middle. If you would like to copy this down into your notebooks, feel free. If not, here is your homework for tonight. Now we are done with Chapter 1. We will have a Chapter 1 quiz next week. If you have any questions, feel free to email me or ask me on the Google Meets. Good luck and have a great weekend.